So hello everyone, my name is Jian Jing. I'm an assistant professor from agriculture and biological engineering at Purdue University. So today I'm going to introduce a new invented technology we just developed at our department. So basically this is a 3D white referencing system for 3D object imaging. So this technology is actually designed for any imaging systems which is designed for any 3D shaped objects. So as you know, no matter if you have an imaging system to image either a plant, a meat product, or fruit products, we have one issue called lighting and uniformity. The issue is there is no way for us to guarantee the 100% uniformity of shining the lights onto any pixels of the surface of the objects. So that is why people have been putting such kind of the white tile. After imaging this plant, we put the flat white tile at the same position, and then finally we use this kind of formula, dividing each of the pixels intensity of the object by the same pixel in the white tile to do this kind of the corrected referencing process. So this works very well for any flat objects, but as you can imagine, if we're imaging any 3D objects, the object is at higher and lower positions. So one problem is, where do we put the white flat tile? There is no best position to cover all the different heights. And another issue is the slope of the object. So let me show you some more information. So for example, for this leaf, for the same pixel at the same position of the leaf, if we image the leaf at a normal direction, and compare that to the image when it is imaged at the tilted direction, the color reflectance is actually dramatically changed. So here is some preliminary data we collected so far. So if we image the same position at this leaf, we try to rotate, we keep the camera at the same position, but we try to rotate the leaf from 0 degree to 80 degree. And then you can see the color information changed. So this is a spectrum information we collected with a hyperspectral camera. So from here to here, a lot of indices could be impacted. So for one example, if you calculate the NDVI index, which is a very popular figure for remote sensing, the NDVI from 0 degree to 80 degree changed from this bar to that bar. So 3 times difference or 300% variance. This is sometimes totally unacceptable based on the customer's requirements. So this is something really we need to this is some problem we really need to solve, but this has so far been a very difficult situation. And so our technology is designed exactly to address this problem. So let me start with this ideal case. So what is the ideal white referencing for any 3D white object, for any 3D object imaging? Instead of using such kind of the white flat tile, we should use some kind of the 3D white reference to reference our object. And the ideal case could be we can put a 3D printer right beside our imaging system. And every time when a new object comes in, we can use a 3D scanner to scan this project. And immediately we use a 3D printer to print the white plastic object with exactly the same size and the same shape as this object. And after this white toy is printed out, we put this white toy at exactly the same position and the gesture as the object to be imaged. And then we use the image of this white plastic object to reference our real object. So this is an ideal case. But some of you may laugh because this is a joke. It is just too expensive and too time-consuming to really print out something in plastic for our object. However, we just invented this technology, and the core part of this technology is actually to virtually reconstruct the image of such kind of white plastic object without really printing this white project out. So this is basically some software and also lighting measurement technology combined together to provide such a solution. So basically, after adopting this technology, the result of your referencing is exactly just like you printed such a 3D object for your object. So how do you do that? There are 3 simple steps. First of all, you just need a 3D scanning device. It can be a Kinect camera, it can be a time-of-flight camera or stereo camera, based on your resolution requirement. So in our preliminary validation project, we used a very simple and low-cost Kinect camera, only $200. Second step is to replace a normally used white flat tile with our new system, which can give you the 3D shape and also the height, different height variation in the 3D reflectance. And the third part is actually you don't need to do anything, but our software will take care of all the slope calibration for you. So how to virtually reconstruct the image of such a white plastic object and use that to reference your result. So the preliminary test result has been very promising. So as you can see in this figure, this is basically the imaging result of a flat leaf, which we rotated from -90 degrees to +90 degrees. So from this direction to that direction. And each of the line we collected here is a color information. It's a spectrum of the reflectance for the same pixel. So as you can see, this is angle rotation. When we rotate the leaf from this angle to that angle, you can see the color change dramatically. However, this is just the traditional method. This is to use a 2D white reference to reference it. We see the variance. After the new technology is adopted with the 3D white referencing, everything is almost the same. So we claim that this experiment was very successful and we were able to accurately calibrate our 3D shape and heights with the new technology. So we believe this technology is not only useful for plant imaging, but also for imaging systems for any 3D shaped objects, like for fruits. You know, people have been imaging apples, oranges, and also the meat products. So we hope that this technology can help a lot of imaging scientists to achieve better results for their 3D objects. Thank you very much.